Okay, so in this video, let's understand what the R squared is. Okay, so up until now, all the performance metrics that we've studied are used in classification problems. The R squared is used for regression problems. Regression is where you have a regressor, and basically, instead of a class label, you have a regressor, which is a real value. It can be anything, negative, positive, whatever. So how I'll just write the formula for R square over here and then I'll break it down piece by piece. R square is given by the sum of square 1 minus the sum of square residual upon the sum of square total. Okay, so what is the sum of square residual? Sum of square residual is equal to the summation I equals 1 to n yi minus y hat. Okay, so what does this mean? That if I have a regressive value for a data point I get a predicted value from my model. Okay, this is square. Yeah, this is square. Sorry. So for every regressive value for a data point that I have, let's say data point I get a predicted value by my model. Let's say yi is equal to 1.21 and y hat, which is the output of my model, it's 1.19. So the difference between them squared is my sum of square residual, okay, for all the data points. So yi minus y hat, sorry, y hat is actually called the residual in linear regression. You can just watch my linear regression playlist if you don't know what that is. This is called the residual, all right? And it's also called the error, okay? Residual is also called the error. And the summation I equals 1 to n is basically ei squared, where ei is the error. Okay, yi minus y hat is called the error. So now let's understand what sum of square total is. Okay, it is basically I equals 1 to n yi minus y bar. Let me write that again. Y bar. Okay, where y bar is equal to 1 by n summation yi, where I equals 1 to n. Okay, so what does this mean? Now, in a regression model, if I'm pretty stupid, or if my model is very stupid, and if I have to give some value, some output for all my regression, for all my regressors or all my data points, what value can I give? Do you agree that I can take the mean of all the regressor values? Let's say y1 is 1.21, y2 is 1.64, y3 is 1.91, and so on and so forth till yn. Something. I have some regression values. Do you agree that I can just take the mean value and output that as my output for the model if it's very dumb, right? I mean, how else would you go about it? You can take median, you can take mean or something. But even if you're taking median, if your data point has a lot of, yeah, you can take median or you can take mean, you can take something, you can take a single value. So y bar is one of that, right? If I have a dumb model and if I want to give some value of uh, for the output, I can give y bar for each data point, right? So SS total tells me how much my data point deviates from the mean. Okay, this is basically the formula for mean. And SS total tells me how much my how much my value deviates from the mean, which is how much my value deviates from the value of a dumb model. Okay, this is square again. I'm sorry, I forgot to put that. What I'm trying to see over here is how much my value of the regressor, this is the actual regressor, it's not predicted. How much does it value from the dumb model? So now let's break down R square case by case. Case 1 is when my R square is equal to 1. Okay, this is the best value you can have for R square. And what does this mean? This means that SS residual is equal to 0, right? Because if it's equal to 0 over here in the numerator, I'll get the value of R square as 1. So what is that? What does SS residual equal to 0 mean? It basically means that my model performed so well that every value it predicted was exactly equal to the regressor value of my of each and every data point that I have, that it performed very well. Like R square is 1 is a very good value. You usually don't get this in real world data sets. But yeah, if if it's equal to 1, that means I don't have any errors in my data set, in my predicted values. So that's case 1. Let's see what case 2 is. Case 2 is R square is between 0 and 1. Okay. Over here, I have some value of I have some value of S as residual, sum of square residual. Okay. Sum of square residual is not equal to 0. That means my model has some errors. But as long as they're small, right? As long as they're small, this is a good way. It's fine. And case 3 is that my R square is negative, which means that SS residual is greater than SS total. Okay. Which basically means that if my errors in the errors that I'm getting in the predicted values are so large that they're even greater than my SS total. SS total is given by a very simple regression model, which is yi minus y mean, right? And if it's much greater than SS total, that means that I can't even use, like, it's performing even worse than a simple model. A very simple regression model is performing even worse than that. So R square negative is not a good thing. You should avoid it if you get the value of R square is negative. Usually we get values of R square between 0 and 1, and a value of between 0 and 1 is fine, and you can see wherever you get the value of R square closer to 1, you can choose that particular model. Okay, so this is what R square is all about.